Hello and welcome everyone to this coding tutorial. Before getting started with the code, I want to familiarize you with the problem. Here we are in a little demonstrational project, which sounds like this. I wrote this polyphonic MIDI sequence, which obviously plays a bunch of chords, and my plugin Xen transposes this polyphonic sequence into 7EDO and then sends out this MIDI so that it can be picked up by Vital and Search XT in MPE mode. In order to transpose notes to alternative EDO scales, you kinda have to put them in between the existing notes. The MIDI 1 standard always assumes that there are 12 notes per octave, which is 12 EDO. But we are in 7 EDO, so the intervals work differently. The plugin does that by using pitch bend information to put the notes in between other notes. But you might be wondering, how does that work? Because there can only be one lane of pitch bend for a whole MIDI sequence. So if there are polyphonic notes, then not every note can have its own pitch bend. But that's only half of the story. Actually, each MIDI note can have its own pitch bend value, but only if each MIDI note in a polyphonic sequence has its own MIDI channel. For example, you could say that all of these notes should be in channel 2. All of these should be in channel 3. And all of these should be in channel 4. If you can do that in your DAW of choice, then that's pretty cool. And I know how to do that in Bitwig, but I don't know how to do that in Cubase, because Cubase just doesn't have these kind of workflows with modern features like that. They didn't expect something like this to happen in the past. And even in Bitwig, I find that this is kind of an error-prone workflow. Like, let's say you're doing this. And now you've accidentally selected a note that doesn't belong here, and you have a polyphonic sequence here if you're not careful enough. Also, if you want to keep on composing, every time you try a new note, you first have to give it a fitting MIDI channel before you can go on. Sometimes you might forget to assign any MIDI channel and then you get confused why the sound is wrong. So yeah, manually assigning MIDI channels is error prone. Also, it's nerdy. People don't like that because they don't understand it. Like, we're musicians, we are trying to make music, not math. And I'm saying that as a programmer, okay? The creative zone is just not the most logical zone ever. Everyone knows that. Also, if you are not like me, I'm someone who likes to type notes into the piano roll, but if you're not like me and you actually like to play on a keyboard, then you would be even more confused by a workflow that forces you to give each note its own MIDI channel manually. So I came up with this feature called AutoMPE, which automatically separates the polyphonic sequence into 15 unique monophonic sequences at all times in order to prevent problems with all of the upcoming effects that have something to do with MPE, like my Xen harmonic rescaler or the internal synthesizer. Basically, this is sort of a voicing feature, but we'll come to that later. The AutoMPE feature was designed so that musicians don't have to buy fancy keyboards only so that they can play very specific microtonal scales sometimes, which is kind of gimmicky. I want people with all kinds of workflows to come into the pleasure of using MPE features, especially my little Xen harmonic rescaler. And in this video, I'm going to show you how the AutoMPE feature works so that you can use it in your own projects. Before getting started, I would like to ask you to donate a little bit of money for me via PayPal or Patreon if you think that it's a noble act to write software that keeps people from having to buy expensive hardware. If you think that's cool, then consider making a donation. Let's get started. Alright, so here we are in the project file of my Xen plugin, specifically in the AutoMPE header. And here you can see the AutoMPE class, which is really simple, only 103 lines, only 3 objects, a MIDI buffer, an array of voices of the size 15, and a channel index. The size is 15 because the MPE standard says that you can only use the channels 2 to 16 of the 16 available MIDI channels for the MPE pitch bend range. The first channel is reserved for more global kind of messages. I have defined a voice as just this little struct, which knows its note value, its channel, and whether or not it's currently playing. The processing method works like this. You are clearing the buffer, then you are iterating through all of the MIDI channels and process them, and at the end you swap the original MIDI messages with the one of your buffer. So basically we want to know now what's happening with this buffer. And the loop shows you what's going on. For each message in the MIDI messages buffer, we are doing something different depending on whether this message is a NoteOn message or a NoteOff message. If it's neither of those, then we are just adding the message without manipulating it at all. We are only interested in messages that represent note values, because those are the ones that have to be put into different MIDI channels. Here you can see the process NoteOn method, which gets the current MIDI message and the timestamp. The main part of the method is basically this. We're incrementing the channel index so that it cycles between 0 and 15 exclusive. Then we get the voice, and if this voice is currently not playing, then we are processing the NoteOn value with this voice, which just means that we get the note number, we inform the voice about it, also about the channel, which is always the channel index +2, and we set it to NoteOn, and we change the channel of the message. So this is the crucial part of this whole processing, because that's the message that will later be added to our buffer. Now you might be wondering, what's all this fuss about with this loop? The thing is, there is an edge case. The user might want to feel very edgy and wants to slam the arms across the whole keyboard in order to find out if they can break the plugin. If they attempt to do that, then I will stop them from being successful with that, with this loop, because this loop checks for each voice if there is an empty one, and if none of the voices are currently empty, then I'm just sending a NoteOff value myself so that I can add another NoteOn. NoteOff processing is handled like this. We're also looping through all of the channels, but this time we're going backwards, starting from the channel index, because the assumption is that the point where we currently are with the channel index is the most present point, the last note that has been added, and it's pretty likely that this note or a note close to it is the one that currently has to be taken for the NoteOff. Then for this voice, we are checking, is this voice currently playing and does it have the same note value? Then process NoteOff. And process NoteOff just sets the channel of this message to the channel that has earlier been saved in the process NoteOn function, and it tells the voice that it can go back to normal, so that the next time process NoteOn value comes across this voice, it knows that it can use this voice. And that's already the entire AutoMPE class. It's really easy to understand. And now I will show you another additional use case that you can have with it, another additional perspective that you can have on it that does not require a context with Xen harmonic scales and all that, not even a context with MPE. This is my synth header, also from my Xen harmonic plugin. It has a class called XenSynth, which is basically more like a voice of a synthesizer, just a single voice. And then there is XenSynth MPE, which is the entire synthesizer. And here we have the processing method, where I'm also looping from 0 to 15, and for each channel, this time it is the polyphony of the synthesizer. I'm getting the voice and I'm getting the MIDI notes. This is an entire MIDI buffer here, and I'm passing this MIDI buffer to the voice in order for it to synthesize into the samples buffer. Now this requires having an individual MIDI buffer for each MIDI channel, which is done by my MIDI split header. You can pause the video and look at it for yourself if you want, or look at the code in my GitHub repository, which is open source. The thing that I wanted to talk about here though is that I wrote a few synthesizers before, and every time I got kind of frustrated because I always ended up writing the voicing in a very similar space as some of the other synthesis and audio processing stuff, and it got so convoluted sometimes that I just didn't want to deal with the projects anymore. But this project was the first project where I felt really safe with my synthesizer, and I think it is because the AutoMPE feature enabled me to sort out all of the voicing stuff before the synthesis even started, so that when it actually comes to the synthesis, you can write extremely simple looking code that just explains itself immediately. And that's why I wanted to share that with you all, so that you know that you can use this for MPE features, but you can also simply see this as a powerful tool to make voicing types of workflows a little bit easier. Alright, I hope I could help some of you getting started with these kind of things. See you next time.